Today we're going to learn how to solve simultaneous equations by substitution. Now the word simultaneous just means at the same time. So we're solving two equations, for example these two, at the same time. Now the reason we're going to need two here is because there's actually two variables. So if I just said solve this equation, y equals 5x, you wouldn't be able to come up with a proper solution for it because there's too many unknowns. You can take any number and let it be x, say 1, and you can multiply it by 5 and you'll get a y. So there's an infinite number of pairs that satisfy this equation. There's also an infinite number of pairs of numbers that could stand for x and y to satisfy this equation. But as we've seen, both of these can be graphed as straight lines, and where those two straight lines intersect, that point, or more specifically the x and the y value of that point, will be the point that satisfies both equations. So we call that the solution to the simultaneous equations because it's an answer to both questions, if you like, or both equations at the same time. Now, you can get questions about simultaneous equations that are worded like this, or you could get questions where you're just asked to solve a pair of simultaneous equations like this. Both of these examples are actually one and the same thing. Let's have a look at why. We'll have a look at this one first. Jill is Jack's older sister. She's 5 times older than Jack. If you double Jack's age and add 9, you get Jill's age. Find their ages. Now, if you're given a question like this part in green, the first thing that you need to do is actually put some letters in. You might let X be Jack's age and Y be Jill's age. You could pick any letters that you like. Now, this question is actually the same thing. Solve for X and Y, because you'll see that if Jill is 5 times older than Jack, then if Jack's age is X and we times it by 5 or multiply it by 5, we'll get Y, and that's Jill's age. So that's the first clue there, put into algebra. To put the second clue into algebra, if you double Jack's age, so if you take X and double it, you'd have 2X, and add 9 plus 9, then you get Jill's age, which is the Y. So these are exactly the same thing, just written in two different ways. And I think this example shows you how you can use simultaneous equations to find the solution to a problem of this sort. All right, I'm going to make some space here by getting rid of this so that we can just have a look at how to solve the algebraic part. Now we're solving with substitution, which means that we've got to substitute or replace something for something else. This is how you do it. Let's read through this. You can jot it down in your workbook if you like, and we'll do each step as it comes. So the first step, look for one equation that has a pronumeral, that's a letter, by itself on one side of the equation. Well, we're spoilt for choice here because both of them have got a letter that's by itself. They've both got the y that's on its own. So this is a nice easy one to do, and we can take either of them to start with. Let's take this one. All right, what are we going to do with it? Substitute the expression that is equal to that pronumeral into the other equation, that should say, into the other equation, and solve. All right, so we can see the y is by itself, but we can also see that the y is equal to something. It's equal to 5x. So what we're going to do is say, all right, well, we'll look at the other equation then, and we'll rewrite it, but in any place that it has a y, we're not going to write y, we're going to write down what y is equal to, which is 5x. So the expression that's equal to that pronumeral is the 5x. And we're going to put that into the other equation where it goes. So I always write down what I'm doing before I then do it. So it's really clear to me what I need to do next. And it's clear to an examiner how to mark my work. They can see what I've done. I'm going to substitute 1. Now you'll notice here I've labelled my equations, equation 1 and equation 2, because that makes it easier to think through. I'm going to sub 1 into 2. All right, now let's go ahead and do it. We're going to write equation 2 down, but we're not going to write the y, we're going to write what y is equal to, which is 5x. So 5x is equal to, now we can just write the rest of this down as it's written there. All right, now we have that. Another way you might like to think through this first line is to say, all right, we know that y is equal to this, but y is also equal to that, so this and that must be equal to each other. After all, if they're both equal to y, they must equal each other. Does that sort of make sense? And that might be an easier way for you to think it through. All right, what have we done now? Well, we've actually eliminated the y. There's no more y's in this equation. So now we can actually solve this for x and see what x has to be, and there's only going to be one answer. All right, we've got x's on both sides and numbers on this side. So the first thing that we want to disappear is this 2x. So this is like our seesaw method, remember? We can tell that 2x to get off the seesaw. We can take it away. But if we're going to take 2x away from this side, we have to take it away from this side as well. Now, if we had 5 x's and we took away 2 of them, this side just has 3 x's left. And this side, the 2 x's are gone now. We told them to get off. We're just left with our 9. Now we can see that 3 times something is 9. So you should be thinking to yourself, 3 3s are 9. X must be 3. And sure enough, it must be. And using your really good working technique that you've learned, divide both sides by 3. After all, this x has been multiplied by 3, so if you now divide it by 3, those will cancel out and you just have x. And x is equal to, of course, 9 divided by 3, which is 3. All right, what do we do with that? We've substituted that expression, 5x, that was equal to the pronumeral that it was by itself, into the other equation, and we've solved it. Last step, sub your solution from b, which is this, into either equation. So it doesn't matter which one, you can use whichever one you like, and solve for the other pronumeral. So we know what x is now, it's 3. And in our example question that was worded, that would mean that Jack would be 3. So now we can sub that in. I'm going to sub it into the first equation because that looks easier. But you could sub into either one and you should get the same answer. I'm going to rewrite this equation, but when I get to the x part, I'm not going to write x. I'm going to write what x is equal to, which is 3. So y is equal to 5. Now, there's no multiplication sign there, but we know that 5x means 5 times x. And here we need to do 5 times 3, which is 15. Now at the end, just write your solution out nice and neatly. Therefore, x equals 3 and y equals 15. And if we were answering that original question about Jack and Jill, we'd say that Jack is 3 and Jill is 15. A trickier example now. Equation 1 has got a pronumeral by itself, y equals something. So the y is on its own, and it's equal to the 2x plus 1. But equation 2 doesn't. So we use the exact same method as before. Look for the one that has something by itself, the y is on its own here, and take what that y is equal to, the 2x plus 1, and substitute it into the other equation in place of the y. So think of it as rewriting the whole second equation, but don't write y, write what y is equal to. So first thing I'm doing, I'm subbing equation 1 into equation 2. Now you'll notice when I put a circle around 1 and 2, I'm referring to the name of the equation, equation 1 and equation 2. All right, so I need to rewrite this equation, but don't write the y, write 2x plus 1 there. So we have 3x plus the y minus 5 equals 0. And now we can solve this. All right, let's gather up the like terms. 3x plus 2x, that makes 5x altogether. Just like if you had 3 apples plus 2 apples, you get 5 apples. So we've got 5 x's, and positive 1 minus 5 gives me minus 4. Again, if you're uncomfortable working with negative numbers, use your calculator in there. All right, I've got x's and numbers on this side and more numbers on this side, or a lack of numbers. I want to disappear this minus 4, don't I, to try and get the 5 x's on their own. So the way I can disappear minus 4 is adding 4. So I'll add 4 to both sides. That'll disappear the minus 4 and I'll just have 5x over here. And on this side, 0 plus 4 is 4. All right, what's happened to this x? Tell the story. It's been multiplied by 5. How do you undo that? Divide by 5. But if you're going to divide by 5 on this side, you have to do it on this side too. And the answer is looking at you, 4/5. You can see here that x multiplied by 5 divided by 5 is just x. So now you can write your answer out nice and tidy. X is 4/5. All right, how do I find what y would be then? Well, I can sub x being equal to 4/5 into either one of these and then solve for y. I'm going to sub it into equation 1 because that looks easier. So sub into 1, Normally I'd work down from here, but I'm running out of space. So I'm going to rewrite this equation, but I'm not going to write x. I'm going to write 4/5 in its place. Y is equal to 2 times 4/5 plus 1. Now at that point you could reach for your calculator and the answer will come out nice and simply. I'm going to do it in my head. 2 lots of 4/5 is 8/5. And that's the same thing as 1 and 3/5. And if I add another 1, I'm going to have 2 and 3/5. Your calculator might have also given you the answer as a decimal 2.6. Either is fine. So even when the answers come out as fractions or decimals, the process is still the same. And at the end you can write therefore x equals and y equals so that your answer is nice and simple.